In this tutorial, we are going to talk about the interference of sound wave. So what is the interference of sound wave? So when two or more sound wave from different sources are present at the same time, they interact with each other to produce a new wave. Now, when you have two waves, when those two waves interact with each other, they are going to produce a new wave. So there are going to be an interference which is going to happen between those two waves. Okay? So under interference of sound wave, one thing you have to understand is that we have two types of interference. We have what we call the destructive interference, destructive interference, interference, and constructive interference. Constructive interference. Now, in some books, you discover to say destructive interference is the same as relative minimum. Relative minimum. So if we're talking about relative minimum, if you come across any question they're asking about relative minimum, then you are talking about destructive interference. Relative minimum. Then this is what we call relative maximum. Relative maximum. So if you come across any question asking about relative minimum, then you are talking about destructive interference. If you come across any question asking about relative maximum, we are talking about constructive interference. Now we are saying that if we have got two waves, if those two waves they are going to interact, they are going to interfere each other. So it can either form a destructive interference or constructive interference. So let's begin our discussion with destructive interference. So what is destructive interference? So if you have two waves, if this is my first wave which I have, okay, it's going in that direction. Let's say the amplitude is 4, okay. Then we also have another wave plus another wave is here. Let's say the amplitude now, instead of it going in that direction, it will go to the positive direction. Let's say we have -2. So the results, if we add these two waves, the amplitude is going to be 4 minus 2, 4 plus -2, which is going to be 2. So the results which we are going to have will be 2. So destructive interference has happened. So this wave is going to be distracted by the first wave. So that's the basic idea behind destructive interference. So it is very, very important for us to understand this. Now, the basic example which you can understand destructive interference is this. Let's say we have sometimes, like I've said, this is what we call, sometimes they'll call it relative minimum or they'll call it intensity minimum. Okay, so sometimes let's say we have a person, let's say this is Mark, this is McDonald, and then let's have two people. I'm going to have Lombe here, then I'm going to have another guy. Let's have Natasha. So if this is Natasha, so this is the person, the distance is the same, okay, the distance from there and also the distance from here. So what we have to understand is that there is a music coming from Lombe and there's also music coming from Natasha. Okay, then Mark has to listen to both songs, okay, which is being played by Lombe and Natasha. So let's say Lombe is playing a song done by Yomaps Kondwa. Then Natasha is playing a song done by Chirewan Nayo Nayo. Okay. So what is happening here is that, let's say the volume, maybe these two guys, Lombe and Natasha, they are using phones, okay, or they are using maybe a speaker or something. Now the volume, let's say that the volume for Lombe, the one for Kondwa, for your maps, is on the volume she has increased the volume all the way to 20. Okay, then Natasha has increased the volume all the way to 15. Now, the distance is the same. The distance from Lombe to where Mark is and the distance from Natasha to where Mark is the same. Let's say the distance here is 6 meters, even here is 6 meters. Okay. Now, one thing we have to understand is that since the volume for Lombe is bit greater than the volume for what? Natasha, then the song done by Chirewan Nayo now is going to be distracted. Mark will not hear anything for Natasha in this case because Natasha's volume is at 15 and Lombe's volume is at 20. But again, it's not that if the frequency in this case at the volume of 20, if the volume is at 20, it doesn't mean that Mark here is going to hear the frequency which is at 20. Okay, some of the frequency is going to be distracted by Natasha. Okay, so now what you're going to do is going to be 20 minus 15. So 20 minus 15 is going to be 5. So that is what you are going to discover. So that is destructive interference. So some of the frequency for Natasha is going to be distracted by Lombe. Okay, so that is what we call destructive interference. So destructive interference is very, very interesting. You need to know and you need to understand this. So like I've said, destructive interference, it is also known as relative minimum or intensity minimum. That is destructive interference. Okay, now that we have talked about destructive interference, let's go ahead and talk about constructive interference. So what is constructive interference? So constructive interference. So we need to have also two waves. So constructive interference, we said, is also known as relative maximum or intensity maximum. If I've got two waves, if these two waves are going to interact, now these ones, they are going to be moving in the same direction. Okay, so if this is 2, the amplitude is 2, there the amplitude is 3. If I add these two, a constructive interference is going to occur, meaning that it's going to be 2 plus 3, the amplitude will be now 5. The wave will be generated in that manner. That is what we call constructive interference. Okay, so now what if I have got the same example which I gave you under destructive interference? Let's say we have two people. Now I'm going to change. This is Betha. Then I have also another person here. Let's say this is Erica. Then this is Annie. So let's say I'll use the same thing. The distance will be the same. Okay, then the volume for this one, let's put that the volume will be maybe at 20. The volume for this one will, let's just put it 10. Now constructive interference will have the same things. So Elika is playing a song done by Yomaps, which is Kondwa. Then also Annie is playing a song done by Yomaps, the same song, which is Kondwa. So it is the same song. Now the volume here, it is at 20. This the volume is at 10. So these, they are going to construct as the voice is approaching Betha. Okay, as the sound is approaching Betha, these two sounds, they are going to emerge, they are going to construct. So instead of just hearing the frequency of the volume of 20, it's going to construct. You are going to add this and that. So you discover to say Betha is going to hear a loud sound than the way it was here, because these two, they are supposed to add up. That is a constructive interference. So they will construct. So that's the basic idea behind these two things. So that is what you need to know under destructive interference and constructive interference. Now let me give you an example. So the general principle which you need to understand is that for a destructive interference to occur, if you want a destructive interference to occur, for a destructive interference to occur, the original length must differ by plus or minus half the wavelength. Then for a constructive interference to occur, the original length must differ by plus or minus just a wavelength. This is something which is very, very important. So the only things which you need to know here is that for a constructive interference to occur, the original length must differ by a wavelength. Then for a destructive interference to occur, the original length must differ by plus or minus the wavelength. Now, why are we saying plus or minus? Let's say that we have got the lambda. Let me just give you an example here. The best example I can give you is, let's say we have two speakers. Okay, let's have speaker A and speaker B. Okay, and let's say the person is here, so the frequency will be the same. That is the person. Now let's say we are saying that the distance here and here is supposed to be the same. Okay, the distance has to be the same. Now if this is 6 meters, this is the person here. So now the question is, what must be L? Let me put L here. What must be L for a destructive interference to occur? What must be L for a destructive interference to occur? Let's assume you always be given the frequency. Let's say the frequency in this case is 40 hertz, or let me put 80 hertz. If the frequency is 80 hertz, and if they are not mentioning anything about the velocity at all, the velocity you use the speed of sound in air to be 343 meters per second. You use this, we are considering the temperature to be at 20 degrees Celsius. But if they are going to mention about the temperature, then you have to use this formula to find the velocity. The temperature in Kelvin divided by 273. So if you have been given the temperature in degrees, you have to convert that. You say the degrees plus 273. Then you plug in. Now if they are not mentioning anything about the temperature and anything about the velocity, we always use 343 meters per second. Take note of that. If they're not mentioning anything about the velocity or anything about the temperature, use the speed of sound as 343 meters per second. Okay. Now the question is, from the diagram which we have here, what must be L so that destructive interference can occur? Okay. So for a destructive interference to occur, so I'll say what must be L for a destructive interference to occur. For a destructive interference to occur, this L must be the original L, because this L and that L is the same, like we said. So it's going to be 6 plus or minus half a wavelength. That's the formula I've given you. So for a destructive interference to occur, the original length, which is 6, must differ by half a wavelength. Now first you need to find the wavelength. How do you find the wavelength? V is equal to the frequency times the lambda. Let's divide both sides by the frequency. So lambda will be equal to V divided by frequency. So this will be equal to 343 divided by 80. So lambda will be equal to 343 divided by 80. That should be 4.29. So 4.29 meters is my lambda. Now that I have my lambda, what must be L for a destructive interference to occur? So L will be equal to 6 plus or minus, then I have half, then 429, like that. meaning that 6, I'll say L has to be 6 plus or minus, I'll say 4.29 times 1 over 2 is 0.5. That is 2.15. Now, the L, it can be two things. For destructive interference to occur, L can be 6 plus 2.15, or L can be 6 minus 2.15. So you say it can either be 6 minus, or I'll start with plus, 6 plus 2.15. So L must be 8.15 meters for a destructive interference to occur, or L must be 6 minus 2.15, or L must be 3.85 for a destructive interference to occur. So for a destructive interference to occur, L must be 8.15 or 3.85. But there are some times where you can just represent this, you can present this in just one answer. You just remove negative, just go ahead with the positive. That is just okay. No one is going to penalize you. Okay? You can just go ahead with just positive. Okay? Now, I'm going to show you, now what about constructive interference? What must be L for a constructive interference to occur? What must be L for a constructive interference to occur? Remember, our lambda was 343 divided by 80. Our lambda was 4.29 meters. So for a constructive interference to occur, the original length must differ by plus or minus a wavelength, meaning L will be equal to 6 plus or minus lambda 4.29. So for a constructive interference to occur, L should be 6 plus 4.29, or L should be 6 minus 4.29. Okay? Meaning my answer will be, for a constructive interference to occur, L must be 6 plus 4.29. For a constructive interference to occur, L must be 10.9, or L should be 6 minus 4.29, or L should be 1.71 meters. So if I have got this constructive interference will occur. But like I've said, it's possible you can just go ahead with just positive. That is just okay. Now, since I've given you the basic idea behind constructive interference and destructive interference, let's go ahead and see how we can work around with different questions. So the first question is, a acoustical system shown in the figure below is driven by a speaker emitting a sound of frequency 756 Hz. If constructive interference occurs at a particular instant, by what minimum amount should the path length in the upper U tube be increased so that the destructive interference occur? Okay. Then the second question is saying what minimum increase. Now in this case we are just interested in increase. Here there is increase, even here there is increase. I'll only work around with positive. If they use decrease, you use minus. What do I mean? We are saying that for destructive interference to occur, the original length must differ by plus or minus half a wavelength. For a constructive interference to occur, the original length must differ by plus or minus a wavelength. So if they use increased, in this case they have specified, you only work around with the positive. If they use decrease, you work around with the negative. Okay, so in this case we just go ahead with the positive. So now in this case, since they are just saying what minimum amount should be the path length in the upper U tube be increased so that the destructive interference should occur. So I'll say I need first to find, I've not been given any information about the velocity. Remember I said if I've not been given any information about the velocity, you use, so this is my frequency, you use V to be 343 meters. So you always find first the wavelength. That is must. So now V is equal to F lambda. So lambda will be equal to V divided by frequency. So lambda will be equal to 343 divided by the frequency 756. So lambda will be equal to 343 divided by 756. So I'm going to get 0.45. Okay, I'm going to get 0.454 meters. That is my lambda. Now, for a destructive interference to occur, remember, the original length in this case, we have not been given any length. In fact, we're not even interested in the original length. So we'll say, for a destructive interference, we're starting with a destructive interference to occur. The original length must, so it's going to be plus half a wavelength. So now, for a destructive interference to occur, it's going to be the length, then half, the wavelength is 0.454. So destructive interference to occur, meaning I'll say 0.5 is 1 over 2 times 0.453 or 454. So meaning 0.227. Meaning that for a destructive, so you say this, since I don't have L, that's why the question is specifying here to say what minimum amount should be the path length be increased, meaning this should be increased with how much. So it has to be increased by 0.227 meters. So you say it has to be, for a destructive interference to occur, the length must be increased by 0. So you say for a destructive interference to occur, the original length must be increased by this 0.227 meters. Then for constructive interference, now you do the same, but for constructive interference, you know that for a constructive interference to occur, the original length must be increased by the lambda. So I'll just say this plus lambda. So it has to be increased. For a constructive interference to occur, the original length must be increased by 0.45 meters. So that is it for this question.